Hello, everybody. My name's Ronald Stanley, and this is my final project presentation for CIT 260, Section 7. And let's go ahead and get this presentation on its way. So, what we're going to do is we're going to start out by talking about the differences between a static class variable and a class non-static instance variable. And we're going to give some examples of how to call those static functions versus a non-static function. So you can see a static class variable is when a variable is declared with the keyword static. It's called a class variable. All instances share the same copy of the variable. A class variable can be accessed directly with the class without the need to create an instance. So we'll see a little bit later on how this works. So for a class non-static instance variables are used by objects to store their values. Variables which are defined without the static keyword and are outside any method declaration are object specific and are known as instance variables. This is because their values are instance specific and are not shared amongst instances. So we'll see kind of how this works here. So when we go to call a static function, we can see here, this is our main stuck on an island.java file that, our main args is in and everything. So we can see here that we have our, so stuck on an island, and we're going in setting our public static game, get current game, return current game, public static void set current game. We're passing in that game parameter. Um, so we can see here an example of how we're calling that function in our game control. So in our game control.java, we have our public static void create new game. We're passing our actor here. And we can see on this second line here that we are calling the class stuck on an island and then calling the function set current game, passing in game. So because this is a static function, we can go ahead and just reference the class. We don't have to create a new object of it. And we'll talk a little bit more about how we call non-static functions here. So you can see here where we have our map class, our map.java. So we have a public class map, and we have a couple of variables here. We have a private string description, a private location array of locations. So we can see here we have public location, get locations, public void, set locations. We're passing on those location arrays. So how this works is what we actually have to do here is you can see in both these lines, we have to create a new instance of this object to be able to call it. So within the map control, we're calling map equals new map. We're creating a new instance of it. Locations equals new location. And we're setting a location of 25. And this is how we do our map. We're setting a array of 25 locations that we can go ahead and call out below, and that we go ahead and make our set of locations for our map with. So next we're going to talk about, we're going to demonstrate through examples of my program, my understanding of when to use an array versus an array list and enumeration or an enum. So this is an array example. First of all, arrays, we're going to talk about a little bit of the differences. It's static in size or fixed length data structure. It can't be changed after it's made, and it can only contain objects and primitive values. So when we go ahead and set this location 25 here, we have 25 locations, and this is fixed. This is a fixed length. After this is made, we can't go in code later and add or take away locations. It's fixed. Another thing to recognize here is it can contain objects and primitive values. So we'll see here in the differences with the array list. It's dynamic in size. It can be changed after it's made. And we'll see later on how we're actually doing that. So as elements are added to an array list, its capacity grows automatically. It's slightly slower than array because it does have to have that dynamic memory. And one of the differences is it can't contain primitive data types such as int, float, doubles, etc. It can only contain objects. So we'll kind of see how that works with working with one of our enumerations. You can see here we have a array list of tool, item, and resource. These are our enumerations that we have. So here you can see this is our public enum resource right here. So it's great when we need to establish a list of items or resources. Anytime you need to have a list of constants that do not change. So we'll see later on where we're accessing this enumeration. This is the names, the enumerations, and then we have here, these are the descriptions for the enumeration. So now we're going to demonstrate through examples of code that I've written for one of my individual assignments, how to use the basic for statement and how to access each element stored in an array or array list. So here we're using a for statement to access an array list. And an example of how we had to a view to print out the resources in the inventory by name and the amount. So you can see here in the switch for a game menu view, we have our view inventory. And what this does is it initially sets all of the counts to 0 for all the different types of resources here. And what it's doing is it's going through and using a for statement to go through the stuck on get current game, get resource, and that's where we have hard coded it in for the purpose of right now. We have hard coded in how many fruits, vegetables, water, etc. we have. So what it's doing is it's going through and for each case of fruit, vegetables, waters, etc., it's going in and adding +1 to that count from 0. So, sorry, after it's successfully gone through and counted for everything, it's going ahead and going to print. So it's going to print you have fruit count fruit. So you have 4 fruit, you have 2 vegetables. So that's an interesting way that we're able to do an individual assignment to show the for statement accessing the array list. So next, we're going to talk about how we throw catch custom runtime errors. So I'm going to demonstrate an example of how I did this. So right here we have the public static int calc health, and this is where we're calculating our health. So we're going to throw our actor control exception here, and for purpose of the time, we're not going to go through that actor control exception, but we're going to show you kind of how it works here. So you can see here we're looking for some parameters that the user is going to be typing in. So if the energy is less than 0 or the energy is greater than 100, we're going to get in and throw a actor control exception saying cannot set the energy to the number you put in, and then because it is not in the range of 0 to 100. And we can see here we have set up for the appropriate variables below. So we're going to see how this works in the code. We can see an example here is please enter your character's last calculated health. So we're going to put 105 here to see if we can catch that error. And current energy 100 times 3, so it's within 1 to 5, 0 to 100, wrong here. Error cannot set current health to 105 because it's not in the range of 0 to 100. So perfect, it works just as intended there. And we're able to throw and catch that custom runtime error right there. Another example of how we're able to do this within the same application is we're actually using a try catch here to see if we put in a valid number. Okay, and right here, this is within our actor control. You can see that we're looking for a number here, and if it's not a valid number, we're going to use our error view.display to say you must enter a valid number. Try again. So let's see how this works here. So in our example, enter your character's last calculated health. We're going to put in some random letters here, and then we'll keep going on putting in our numbers. And oh, look there, we have an error. You must enter a valid number. Try again. And then it will go ahead and start right at the beginning here to enter your character's last calculated health. And it will keep doing that until we put in the right input that the program is looking for. So that's really cool example of how custom runtime errors work and try catch blocks. So next we're going to talk about the differences between character streams versus byte streams. Now, Java initially only supported byte file streams. Byte file streams are limited because it reads and writes binary data 1 byte at a time in sequential order. It must read and write data in ASCII format. However, the default format for storing character data in Java is Unicode. Byte file stream can't support Unicode. To combat this, character file streams were added to Java. Character streams allow you to read and write data character regardless of format. So it supports both that ASCII and Unicode format. And this should be used anytime you print a report to the console, a text file, or to a paper. So that is the preferred method there. Now, what we'll do is we'll go ahead and look at an example of how we write character data to a file here. So we have a switch statement up above where we are printing a inventory report, and what it's going to do is we're going to use our get input setting to a string inventory file path to enter. So the user is prompted to enter the file path for inventory item report to be printed to. So we're going to see how this works. The next slide. Pretty much you put in your file name, and then it's going to tell you if it's successfully printed. And then right here, it's going to get passed down to the print inventory report, and it's going to pass into our array list resource. So we're going to see it's going to use a try catch here to watch for any errors, and it's going to pass in that inventory file path and print writer, use that to print it to it. And that's the character string that we're using. So we go ahead and set up the basic formatting here, and it's going to use, like we talked about before, a for statement to go through and get the name and the description for that resource item nutrition, and then it's going to print it out, and it's going to tell us if it successfully printed. So here we can see enter the file path for the inventory item report to be printed to, report.txt, and resources printed to report.txt successfully. And we can see here that is the item and the description and how many. So that's pretty cool. Okay, so we only have a couple more minutes left, so I'm going to quickly jump into NetBeans, and we're going to look at a couple of cool parts about our game. So here we have NetBeans. And so right when we start the game, we're prompted with a little game description here. Welcome to the game, Stuck on an Island. In this game, you will crash on the island. You will have the opportunity to gather resources and make your way off the island by building a raft. Good luck and be smart out there. So we're automatically prompted to enter our name. So go ahead and type in Ronnie here. And then we're brought to our main menu. From here, we can start a new game, continue to save the game, restart the game, get help on how to play the game, save the game, or quit. So let's see what we need to do for this game. Let's go ahead and check out the help menu. So we're going to check out the help menu here. And here we have what is the goal of the game, how to fast travel, how to build tools, how to gather resources, how to build the raft, etc. So let's just see what the goal of our game is. Looks like the goal of the game is to build the raft and escape the island. Okay, so how do I build the raft? In order to build a raft, you must gather wood, vine, and have the proper energy to be able to work on the raft. You must also have the proper tools required to work on the raft, which will be showed to you later. Okay, cool. So let's see how our health works. Health is important in order to keep you alive and be able to escape from the island. In order to keep your health in order, you must keep your energy high. If your energy drops below 50, you will lose health. If it drops below 20, your health will be lost at an even faster rate. Health will be assessed every 1 minute. Okay, cool. So let's go ahead and back out of our help menu here by pressing Q, and we're back in our main menu. So let's go ahead and start our game. So when we start our game, we're automatically brought to the game menu. So here we can see a quick few things. So at some point in our game, let's see, we want to go ahead and display our map and see where we can go. So here we display all of our map locations. So we can see here we're a location Shipwreck Beach, location home. We have a tool building shop. We have a raft location. We have a bunch of gathering locations here where we can collect resources that we need for our adventure. And then here you can see what type of scene we're working in. So this is a normal scene. This is a build scene. This is a raft scene. So let's go ahead and look at it, maybe a few calculations that we did. So we put in the option to be able to check your energy and health. So let's go ahead and check our health. So we'll go ahead and put in H to check our health. Enter your character's last health. So we kind of saw this a little bit in our examples. I can put in, we had 100 health. Our current energy is 20, so our energy is really low. And it's been 3 minutes. So our new final health is 40. So because our health energy was so low, for each minute we lost 20 health there. So that's not good. Now let's see. Let's look at some of the tool resources that we have in the game. Oh, we have fruit, vegetables, water, wood, vines, and rope. Let's look at some tools that we have: axe, knife, and hammer. Bunch of things we can do. We can go ahead and print inventory report, print tools report. I kind of showed you guys how that works in the example already, so I won't go through that. And then, we have a bunch of menus here that are being implemented. We can check our energy. We can calculate our water storage capacity. So a lot of stuff that's working that we're super proud of in this game. We're out of time, so I'm going to go ahead and end it here. But I really hope you enjoyed my presentation, and it's been a blast. Have a good one. Thanks.